Hey everyone, good afternoon. Like Randall said, we're going to do an MCP security deep dive here. So my goal here is really to show you kind of like when you connect MCP tools to your agents and LLMs, what's actually happening underneath the hood, and what are the security considerations that we need to take into account based on those protocols. So well, I'll introduce myself here quick. I'm the co-founder of a new company called Keycard. We are doing AI identity and access management. I'm also the creator of Passport.js for any Node devs in the audience. It's very popular and also quite old at this point, authentication framework for Node, but widely used. I think it's like 4 million downloads a week or something like that. Been super fun experience to maintain a popular open source project. Prior to Keycard, I spent the past 10 years between Auth0 and Okta. I was very early at Auth0 and built out a lot of their core identity infrastructure. So I'm a huge identity nerd. I love OAuth. I love OpenID Connect. So here to chat with you all about that. Okay, well, what's the main thing that we're all interested here? Well, agents that are more connected are more useful. We've all been discovering that as we build out MCP and agents. Tons of value to be gained here as we connect agents to different data sources, different tools, let them take actions. But there's a problem today, and we kind of face an impossible choice. And this is like reflected in the configuration files you see when setting up MCP servers. We're just sitting here pasting static secrets into environment variables, and we're faced with this trade-off of we can give agents broad access and accept the security risks that go along with that, or we can just limit their access and sacrifice the business value that we gain from the agents themselves. So what do we need to do about this? Well, we want to connect the systems. Let's just do it securely. And so this is where OAuth comes into play. OAuth has been around for quite a while and is now adopted by MCP. And it gives us the ability to basically just issue dynamic tokens, kill static secrets that are sitting around, and now we can build secure systems. So I'm going to kick this off with a quick intro. Show of hands, who's done anything with OAuth or OpenID before? OK, decent. So for the rest of you, I'm going to just intro this real quick. OAuth can be fairly complicated to get your head around, especially if it's your first time seeing it. So I'm going to try to simplify it as much as possible, and hopefully this resonates with folks who are familiar with it. So what is OAuth? OAuth is a protocol for applications to request access to APIs. In OAuth terms, we refer to these applications as clients. In the APIs, we call them resource servers. And the thing that mediates the access is what we call an authorization server. So to put this in a real-world scenario, a lot of us probably use Calendly. So you see this sort of flow when you set up Calendly is Calendly wants to connect to your Google Calendar or your Microsoft Calendar or wherever your calendar lives, right? And Calendly needs access for that. So what it does is it sends an authorization request to Google saying, hey, I would like to access this user's calendar. And you see in that authorization request, there's a client ID that OAuth calls it. I'm not going to get into too much of the details here, but Google steps in and says, it tells you what's happening. It says, do you really want to give Calendly access to your calendar or not? And you click yes. And what happens is Google issues an access token over to Calendly that allows the access to the Google Calendar API. And the central problem that this fixed way back in the day, it feels old now, is a pattern used to be common, and you still see this, unfortunately, in some cases, where Calendly they never did this, but the pattern was you'd actually ask for the user's password. So people were just handing out their passwords to a bunch of applications in order to do integrations, and now your password is everywhere, which is a big problem. And this sort of indirection between the authorization server allows Google to issue what's known as an access token to Calendly. And that thing is ephemeral. It's not your password. It's unique to Google and Calendly. You can revoke it separately from your password. All sorts of good security properties come from this. A couple things kind of fall out from this as OAuth evolved is we usually call OAuth an authorization protocol, so you're accessing APIs. But one of the patterns that became super common is to use OAuth for authentication. And then we get into these authentication versus authorization discussions. What exactly is it? That stuff doesn't really matter. The key thing to show here is that when we use OAuth for authentication, what we're doing is just swapping out the API that was the calendar API in the previous example for a user info API. And that's just returning information about the user who authenticated to the authorization server. And this became so common that eventually this pattern was standardized in what's known as OpenID Connect. So we just get a standard user info response there. We can code against a single protocol that multiple people can implement. And that's what gives rise to OpenID Connect. And we see this a lot for SSO now. And OAuth is sitting underneath that protocol. A couple other things to just note about OpenID Connect, not super important for this particular conversation, but OpenID Connect also introduces what's known as an ID token. So we've got the access token and refresh token from OAuth, and we've got the ID token from OpenID Connect. There's a few interesting properties about that. One, it can be verified independently of calling an API, which is kind of nice. And there's also some interesting session management, ongoing session management that you can do with the ID token that is also kind of nice. This stuff hasn't really surfaced yet in MCP. I sort of suspect it will over time, but MCP is evolving quite quickly, as we all know. And then final note here is these protocols often get used in combination. So we'll just run flows that do both authentication and authorization at the same time. Nothing too special about that other than we're just consuming either multiple APIs or multiple different tokens. So that's the broad strokes of OAuth. There's a lot more underneath the hood. But let's take a look at how this applies to MCP in particular. So MCP has adopted OAuth 2.0 as its security layer and also many, many OAuth extensions, which are interesting but kind of unique to what's happening with MCP in particular. And a lot of these extensions haven't seen a lot of use in practice within existing OAuth deployments. So there's a lot of new, unique security properties and challenges that we're facing with them. And we'll talk about that a little bit here. So we're going to walk through a flow, which is basically what exactly happens when a user adds an MCP server to their cursor, their Gemini, et cetera. OK. So, and if there's any questions as I go through this, feel free to jump in. I like to do things a bit interactive. But yeah, jump in. So first thing happens is a user says, I want to connect to an MCP server. So the user puts that URL into their particular agent. I just threw Claude up here for an example. That could be through a JSON configuration file or a new one-click button that a lot of applications support, which is a nice usability affordance. And then the agent turns around and says, OK, I'm going to go connect to that MCP server. So it makes a simple HTTP request for remote transports here over to the MCP server using the URL that came back. And for authenticated MCP servers, what happens is it issues a challenge back to the agent, to Claude in this case, and says, you're not authenticated. You need to get authenticated. And now it's up to Claude to figure out how it gets authenticated. And we're going to walk this through. So we're going to just burn down the protocols that are happening underneath the hood here. So the first thing that happens is the MCP server in OAuth, what we would call the resource server, responds with a challenge and says, you need to authenticate. Here's information about me. That's that resource metadata. So it provides a URL for Claude to go get more information about the MCP server. Now, there's going to be a whole sequence of chatty requests that happen here, but Claude says, OK, I need to authenticate, and here's how I learn more information about how to do that. I'm going to fetch the protected resource metadata that you just challenged me with. It goes off and does this. This is also hosted by the MCP server itself. So Claude says, give me your metadata, and the MCP server responds with a bunch of metadata. I've elided it here. But the key point here is it's returning the authorization server that protects this MCP server. So this comes back to the OAuth authorization server. This is the URL you need to go seek an access token for to connect to me, is essentially what the MCP server is saying. Claude now says, OK, that's the authorization server. I need to go find out more information about it. So we follow a similar pattern here, but now we're fetching authorization server metadata rather than resource metadata. And it goes and just makes a simple fetch call to that URL. This one's a little bit more involved. This is the data that the authorization server responds with. It responds with a whole set of endpoints that allow the client to proceed to make OAuth requests with the authorization server. The ones that are particularly notable for MCP are the authorization endpoint, the token endpoint, and the registration endpoint. And we'll get to all of these in a sequence here, but we're going to start with the registration endpoint. So one of the things that's kind of unique about MCP and OAuth that's different from how it's been traditionally deployed is clients need to register with the authorization servers that they talk to. In particularly, they need a client ID, and there's a couple other things that are important in that protocol. Traditionally in OAuth, what happens is this is all done ahead of time by the developer. So in the Calendly use case, Calendly has previously set up a relationship with Google. They have all this information to talk to Google directly because these integrations are typically point-to-point. This is very different in MCP because we see users enter MCP URLs that the agents or applications have never seen before. So they don't have a prior relationship with the authorization servers and MCP servers that they might be talking to. So the client does, in OAuth, what's called dynamic client registration with the authorization server. And all this does is basically post some information about the client to the authorization server. And the authorization server then responds back with information that the client needs, in this case, a client ID. Now, there's a whole set of kind of like security concerns that arise from this. In particular, a lot of this metadata is not actually validated. It's just the client can assert whatever it wants. When you have applications running on desktops that use like localhost style callback URLs, it's very hard to verify these things. There is some talk about how this stuff gets fixed, and that will probably be showing up in future MCP specifications. But for now, this is kind of the status quo about how clients register with authorization servers. Now, once we've done that, now we're actually to OAuth as it's existed for a while. Everything that's happened in the 4 or 5 requests that precedes this slide is all new OAuth extensions that are unique to MCP. All right. There's other communities that use them, but MCP is the main driver right now. So once Claude now has a client ID for the authorization server, it can go ahead and make authorization requests to it saying, hey, I would like access to the MCP server that the user is trying to connect to. And this is where OAuth kicks in. We do typical login and consent flows, and then ultimately issue tokens back to Claude. So that looks like this. There's another request. Now we're back to one thing to note here. Now we're using the authorize endpoint. So if we kind of go back to the metadata that we've seen, now we've finished with the registration endpoint, and we use the authorization and token endpoints to obtain tokens. The authorization request goes to the authorization endpoint first. That responds with a code. This is kind of a weirdness of OAuth that I'm not going to get into. But once it has the code, now Claude can say, hey, give me the access token that the user has now approved. And once Claude has the access token, it can jump back now and talk to the MCP server the same way it started this whole process. The one difference now is that it has an access token it can include in the request that authenticates itself, and the MCP server says, that's great, I will let you in now. And now we can start to kind of use those tools and those resources in our chat interfaces, or our agents can consume the tools. And everything is sort of nicely working at that point. So that's the current state of affairs of what's happening with MCP and OAuth. Let's take a look kind of like briefly, what are sort of the threat models that we encounter here? We could probably do a week-long workshop on all the sort of like details of the threat models behind this, so I'm just kind of giving a preview of this. MCP inherits a whole bunch of stuff that has its own unique security properties. Starting with OAuth 2, there's whole books written on the security model of OAuth 2, and we've had probably 15 years or so now of experience of defending those and preventing vulnerabilities, even though occasionally we still find some new ones. HTTP authentication is obviously one of the protocols that happens underneath the hood after access tokens get issued. And then dynamic OAuth. And this is unique now to what we're seeing with MCP and a couple other protocols. This changes a lot how OAuth interactions happen, and it's kind of exposing some new challenges here, new security things that we haven't really seen before in OAuth for the past 10 years or so. A couple things to call out is because resource servers now sort of dynamically say which authorization servers protect them, there's capabilities for mix-up attacks there, which is something you'll probably see being talked about a little bit more. People are realizing that there's a threat model there that isn't totally solved, although there's proposals on how to solve it. And there's a few other things that kind of fall out of this dynamic nature. There's what I showed with client registration is clients can just anonymously register themselves. Those things end up usually creating records in databases. So databases can fill up with tens of thousands, hundreds of thousands of records from these anonymous clients trying to register. That creates all sorts of denial of service and resource exhaustion attacks, and things to consider around that. And then finally, you've got MCP itself, which is obviously a new protocol that hasn't had a lot of security analysis and review. And then LLMs, which are magical, but also scary in the sense of what they do. And all of these things kind of come together in what's happening here with MCP and OAuth. Now, I want to take a look at some of this stuff is like, when we talk about MCP and what you see in the specification, it's really about the MCP client and the MCP server and that leg of communication. MCP doesn't really concern itself with any security aspects that happen outside of that. But in the architectures that we deploy, MCP is often combined with other things that you need to consider for end-to-end security. So security is more than just the client-server considerations here of MCP itself and OAuth. And let's take a look at a couple of those things. So one common pattern that's happened with MCP to date is that you might front existing APIs of some sort with MCP servers. So a lot of people just by nature of deploying SaaS and web applications already have your typical REST API, and now they want to expose new MCP servers to agents so that users can use them via those sorts of interfaces. And so typically what those MCP servers do is kind of like wrap the API, kind of put a tool interface on some of the common workflows behind the API. And so the user to agent to MCP server leg of communication here is what we just kind of covered. But then the MCP server itself talks on the back end to other APIs. OAuth has some answers here for how you can think about deploying these things. So there's a specification called OAuth token exchange, which is particularly useful when you want to access services that exist within the same security domain. This does a lot of nice things. It allows you to prevent token pass-through. So this gets called out a lot in the MCP community because people will sort of take tokens issued to the agent, send them up to the MCP server, and then send them on further down the line. This is a big no-no, creates all sorts of security problems. Each leg of this communication needs to be treated as its own independent access and authorization layer. And so token exchange gives you the primitives to do that. Another common pattern is that there's a whole set of APIs out there that don't have MCP servers for them. So third parties write MCP servers to front those APIs. This is kind of a variation on what I just showed. The main distinction here is that we cross security domains. Someone might write an MCP server for the Google Calendar API, in which case we can do techniques like OAuth token brokering. And that's particularly good when you cross these security domains. And then OAuth, this is really not OAuth related, but a lot of these MCP servers will also consume other internal services, Postgres databases, Redis, et cetera, that aren't OAuth enabled. And you just typically do TCP plus SASL, or whatever the requirements are of the particular quote unquote legacy service. This is very much deployment specific in terms of how you choose to secure these things. Service meshes, et cetera, are common. But just keep in mind, again, the key point here is that as you sort of do these two-phase things, you need a separate security layer between those communications layers. Finally, I want to take a look at some of the interesting things that are now happening with MCP plus front-end development. So what MCP has been, to date kind of considered is that the MCP servers that you're building are OAuth-protected resources. You think of them a little bit like APIs. But this is evolving pretty quickly, and MCPs also have the capability to be OAuth clients. They can interact directly with users. There's a couple things. These are not widely deployed yet, and not even in finalized versions of the MCP specification. But there's a new feature that will probably be landing pretty soon, which is called URL elicitation. It's somewhat of a strange word, but all this does is says the MCP server can request the agent to pop open browser windows. So this is particularly good if you want to do sort of sensitive security operations, but you want to do it outside of the context of the LLM, because you really don't want those credentials entering the context window at all. So you can pop open a browser, do things like payment flows, do things like OAuth flows, prop for credentials. And this is very, very interesting. But one thing to call out here is it creates two separate channels by which users interact with MCP servers. We've got our existing sort of MCP session that goes on from the agent to the MCP server. And you've also got this separate browser session that's now happening. And I'm sort of predicting that this will be a cause of a lot of security vulnerabilities, because we have to manage channel binding between these two things in order to sort of leak access crossing that boundary, or allow attackers to attack one of the channels and intercept the other channel. So keep that in mind as URL elicitation rolls out. Again, extremely interesting capability, but a lot of security concerns there to watch out for. This next one is, this is changing super fast, and I'm not super well versed in it, but I would consider it even the next evolution of URL elicitation, which is we now have the capability to embed iframes directly into agents, so chat windows. This is coming up in MCP UI, which is very early. Probably a lot of people are not super familiar with it. But also what OpenAI announced with the Apps SDK and sort of embedding widgets directly into ChatGPT. That's different from MCP UI, but these communities are collaborating, and some of this stuff will converge. The key point here is now we've got browser windows inside iframes, inside agents. I have no idea what this means, but anyone who's done anything with security in iframes in the past probably has a lot of scars to show for it. So as this stuff rolls out, expect a lot of changes, a lot of security challenges, and we'll all have to fix those things together. But very, very interesting, again, in terms of user interfaces that we can now drive with MCP. So taking a look at those additions to what's coming to MCP, we have all the existing stuff that we mentioned: OAuth 2, HTTP authentication, dynamic OAuth 2, MCP LLMs. We have also got infrastructure security concerns for our backend communication, and we've got all the properties of web browsers and their security model. All of this stuff is converging in MCP and the agents we're building, and I almost like to look at this as security's final boss. It's if AI was the ultimate goal of computing, then all of this is coming together to make just massive security challenges that we'll have to address and keep in mind as we build these AI applications. It's both fun and exciting, but also a bit daunting. I'm just going to throw up some topics here for further reading. You can Google these or throw these things into your agent and get back information. Good documents to read here for all the deep details. There's a RFC called Best Current Practice for OAuth 2 security, which is very comprehensive about all the sort of attacks we've seen on OAuth 2 and how to remediate them. There's MCP security best practices, top 25 MCP vulnerabilities, and the OWASP Gen AI security project. All excellent references for detailed threat models and security analysis of these protocols. Finally, just quick plug here. At Keycard, we're building infrastructure that helps deal with this. We supply OAuth servers that protect your apps, services, and infrastructure, and you can bring any agent to Keycard. So your existing co-pilots like Claude, custom agents that you build with third-party frameworks, or just other third parties shipping their own agents. And Keycard.ai is our website. We're hiring. We're looking for design partners. Really excited about securing AI with everyone, so hit us up and let's chat. All right, I think I've got 4 minutes left for questions if anyone has any. Yeah. Say that again. Local drivers, I think, like for the purposes of MCP and like OAuth, it's mostly remote MCP servers. Local drivers have a lot of other security considerations, but this mostly applies to remote MCP servers. Yeah. No one else? All right, thanks everyone. Really appreciate it. Yeah.